Still confused between lithium aluminum hydride, sodium borohydride? This one trick ends the confusion today itself. Hello students, let us start. Reagents for part 2, that is reagents for reduction part 2, reduction of metal hydrides, lithium aluminum hydride LiAlH, where LiAlH provides H minus, H3O plus provide H plus. So after overall 2 steps here, secondary alcohol is found from ketone. If I take aldehyde here, it gives primary alcohol. Overall what we need to remember, lithium aluminum hydride gives H minus, H3O plus gives H plus. For example, if any isotopes like lithium, aluminum, deuterium based given, so D minus we need to attach at carbon, H plus at oxygen. See here, D minus attached at C plus, hydrogen at oxygen. So overall plus or minus mixture, because it is optically active component, is overall plus minus mixture, meaning here racemic mixture you will get. Racemic mixture is optically inactive overall. So LiAlH generally does not reduce double or triple bond, but it reduces double bond of cinnamyl system. That is when double bond is present between pH and CO, like pH in this system, pH and CO system, if there is double bond, then it can reduce it. See here, cinnamic acid, it can reduce double bond also. Aldehyde, lithium aluminum hydride, primary alcohol, ketone, secondary alcohol, acid, primary alcohol, anhydride, primary alcohol, acid chloride, primary alcohol, ester, primary alcohol, cyanide, primary amine, amide, primary amine, isocyanide, secondary amine, nitro compound, primary amine. So all combinations given. Once if you know these combinations in particular pattern, any question you can solve without any confusion. Sodium borohydride, NaBH4, mild reducing agent if you compare with above reagent. Function is same like LiAlH but milder than LiAlH. So here only few groups you have to remember. Aldehyde convert into primary alcohol, ketone convert into secondary alcohol, acid chloride convert into primary alcohol. Only these groups reduced by SBH. SBH cannot reduce COOH, cannot reduce NO2. Alkyl halides, primary and secondary, LiAlH can convert into alkane. But alkyl halide tertiary, LiAlH can convert into alkene. Second and tertiary alkyl halides, SBH can convert into alkane. Primary alkyl halide, SBH no reaction. So these combinations you have to remember. Primary, secondary, tertiary alkyl halides in presence of PH3SNH, it turns into alkane. For example, if I take double bond between cinnamyl system, that is PH and C double bond O, between these two if there is double bond, LiAlH can reduce even this double bond along with carbonyl group. But SPH, double bond cannot be reduced by SPH, even it is between PH and CO. And here one example you see here, sodium borohydride, SPH cannot reduce ester. See here, this ester group is as it is. Only carbonyl group convert into alcohol here. But lithium aluminum hydride, it can reduce carbonyl group as well as ester group into OH, that is alcohol. It can reduce into alcohol. Diisobutyl aluminum hydride, DIBAL-H. So diisobutyl aluminum hydride, here source it produce H minus, mild reducing agent. Cyanide on reaction with LiAlH gives amine. Cyanide on reaction with DIBAL-H gives aldehyde. Mild reducing agent stops at aldehyde stage itself. DIBAL-H 25 degrees Celsius gives primary alcohol, 2 alcohols here. Ester on reaction with DIBAL-H 25 degrees Celsius gives alcohol. At minus 78 degrees Celsius gives aldehyde. Important, temperature minus 78 degrees Celsius gives aldehyde. Cinnamaldehyde, where there is double bond between PH and CHO, LiAlH can reduce even same double bond, but DIBAL-H cannot reduce, it can reduce only aldehyde into alcohol. DIBAL-H, acid chloride gives aldehyde, DIBAL-H. One reference table given for you, that is overall role of LiAlH, NaBH4, DIBAL-H respective groups given. So this overall table gives idea about how it can convert respective functional groups into other form. So this you can refer it properly so that no more confusion in future questions. Okay. Next, MPV reduction, Meerwin-Pondorf-Verley reduction. It is selective reduction of aldehydes and ketones to alcohols. Aldehydes and ketones to alcohols using aluminium isopropoxide plus isopropyl alcohol. So these two together we used as reagent. Here aluminium isopropoxide gives hydride H minus, isopropyl alcohol gives H plus. So what happens is, see, H minus attack at carbon, H plus from isopropyl alcohol attack at oxygen. Overall you will get secondary alcohol plus after removal of this acetone is formed. Here acetone is formed, here secondary alcohol is formed. If it is aldehyde, it forms primary alcohol. If it is ketone, secondary alcohol. Acetone is byproduct during the process. Open layer oxidation exactly reverse of MPV reduction. Here what happens? Acetone as well as isopropyl, aluminum isopropyl oxide. Here it is reagent. So what happens here? Alcohol and open layer oxidation, O oxidation I mentioned, open layer oxidation gives aldehyde. Secondary alcohol gives ketone. Exactly opposite. Previously what happened? Carbonyl group converted into alcohol. Here alcohol converted into carbonyl group. Okay, exactly opposite to previous one. By using red phosphorus and HI like acid, aldehyde, ketone, acid chloride, acid anhydride, ester. Any of these groups on red phosphorus HI reduction gives alkane. Cyanide amide gives primary amine. Isocyanide gives secondary amine. Nitro will give primary amine. For example, see here ester group convert into alkane in presence of red phosphorus HI. So here mainly what you need to focus, if you remember these combinations, any future question based on any functional group, once if you remember the functional group combination, any question you can solve it. So these tricks saves you lot of time without any confusion. Let's see. JEE Mains 2019 question here. Observe it everyone. Okay. See question here. Here they gave compound which is on sodium borohydride MEOH 25 degrees Celsius. So what happens during this reaction? See here. First it converts. Here it converts the group whatever given into alcohol, like you can convert it into CHOH. First step. CHOH, CH2Br. Later, here it is intramolecular cyclization occurs. Intramolecular cyclization. So, how intramolecular cyclization occurs? Overall, it leads to formation of one epoxide ring type it is. How? So, here for example, if I see intramolecular cyclization, here this what we can specify here. So, ring formation occurs by the removal of bromine here. From the compound bromine removed, intramolecular cyclization after removal of HBr. So, overall which is fourth option, intramolecular cyclization. 2019 JEE Mains question. Simple. First what we are doing here, carbonyl group convert into alcohol, after the intramolecular cyclization occurs and final product is this one, fourth option. Next, JEE Mains 2017 question, DIBAL-H based diisobutyl aluminum hydride based question. So how we need to solve such questions? See here. Observe first question everyone from your side. So what we need to do here, we know DIBAL-H cannot reduce COOH. Already above we discussed, it cannot reduce COOH, but it can reduce cyclic esters. What happens? During reduction of cyclic esters, after opening the ring, wherever there is CO group, that is converted into aldehyde, other part converted into alcohol by opening the ring. So it should be this one without disturbing COOH. Here it can reduce overall here carbonyl group into whatever CO group into aldehyde form. At the same time, whatever O convert into OH. And finally, if you see here, according to given information, which is correct. Observe it. OH here it is CHO. Option 2 is correct. So, if simple modification, what you have to do? Carboxylic acid cannot be reduced by DIBAL-H. So, leave as it is. Plus, it can reduce esters to aldehydes. Aldehyde and one more group after opening alcohols. Aldehyde as well as alcohol here together. So, this group is correct. Pattern you have to remember. Above I gave all combinations. So, if you remember that, easily can frame it. I hope all the questions clear to everyone. For more updates, follow the channel. Thank you. Thank you everyone.